Lesson 39, Patterns and Functions, Part 3. Now that you've watched the videos and had a chance to look at the lines and complete the table, you've identified the slope and the y-intercept. Let's go back and review. For graph A, we see that the line crosses the y-axis at the 2, and then the next point, 1 is 3, and the next point, 3, is 5. So let's write those points in. When x is 0, y is 2. When x is 1, y is 5. And when x is 2, y is 8. And there are a few points in between. Let's look at the slope of this line. If we do rise over run from one point to another, we notice that the graph increases from 2 to 8, it goes up 6, and across it goes over 2. So rise is 6, run is 2. 6 over 2 simplifies into 3 over 1. The slope of the line is 3. When we look at the table, when we go from 2 to 5, 2 plus 3 is 5, 5 plus 3 equals 8, and 8 plus 3 equals 11. And we can continue filling in the table that way. 14 and 17. That is the slope of our line. Now let's look at the y-intercept. The line intercepts the y-axis at the positive 2. And you will see in the table that when x is 0, y is 2. When x is 0, y is 2, making 2 the y-intercept. In graph B, the line crosses the y-axis at negative 2. When x is 0, y is negative 2. When x is 1, y is 0. When x is 2, y is 2. Let's look at the pattern. Rise over run. We went up 4 and over 2. Rise is 4, run is 2, which simplifies into 2. And indeed in our table, negative 2 plus 2 equals 0, 0 plus 2 equals 2, 2 plus 2 is 4, 4 plus 2 is 6, and 6 plus 2 is 8. But let's look at it again on the graph. We said 4. When x is 4, y is 6. So let's go over on our graph, over 4. And indeed, we end up with a point on the line. That point, we would write it as 4, 6. And that is indeed a point on the line. Now, let's look at the y-intercept. We already said that the line crossed the y-axis at negative 2. So negative 2 is our y-intercept, which we then have here in our table. So, for graph B, the slope is positive 2. The y-intercept is negative 2. Let's look at the third example. In the third example, we see the line crosses the y-axis at 1, right here. And then again, when x is 1, y is 6, and when x is 2, y is 11. And we can just find that by looking up the line. So let's fill in the table. When x is 0, y is 1. When x is 1, y is 6. When x is 2, y is 11. Now let's look at rise over run. Rise over run. And you can go from any 2 points. It doesn't really matter. So in this case, we went from 1 to 11, and the rise was 10, and the run was 2. 10 over 2, which simplifies into 5. So let's see if the slope is 5 in the table. 1 plus 5 equals 6. 6 plus 5 equals 11. Now let's continue the pattern, and we see 11 plus 5 is 16. 16 plus 5 is 21, and 21 plus 5 is 26. Now let's look at the y-intercept. In this situation, the line crossed the y-axis at positive 1, and here in our table we have positive 1. So the y-intercept is positive 1. The slope of our line is positive 5. Now the slope doesn't always have to be a whole number. In fact, it's mostly written as a fraction, 5 over 1. But we're simplifying in this case. Alright, so now that you know the slope and the y-intercept for each of these graphs, how can that help us find the value of y for any x? Because we certainly don't want to keep counting and adding the slope, adding 3 all the way to 100 or 200. So instead, we can write an equation, and we can look at what happens to x to get y. How can we go from x to y? So, how can we go from 0 to 2? Well, we could just add 2. That seems pretty basic. But we can't just add 2 from 1 to 5. Instead, we multiply the x by the slope, and then we add the 2, the y-intercept. So 3 times 1 is 3, plus 2 equals 5. Let's see if that works with the next example. 2 times 3 plus 2, and yep, that equals 8. So our equation is x times 3 plus 2. And we can actually turn that into an entire equation by writing 3x plus 2 will equal y. In this way, we can put in any value for x, solve the equation, and we know the value for y. And we know it will be a point on the line. Now it's your turn. For graphs B and C, complete the table and write the expression for any value of x.